In this video, we are going to see what will happen to current, voltage and power through in the case of a pure RL series circuit when an alternating current flows through the circuit. And based on this, we will see the Phasor diagram and the waveforms regarding with this and voltage triangle, impedance triangle, and we will derive an equation for the instantaneous power in this series RL circuit, and we will see the power triangle and power factor, and finally based on this we will see the quality factor. Okay, these are the main portions involved or included in this video. For this, first we can see here a series RL circuit. You can see here Vm sin omega t is the instantaneous value of voltage which is supplied by this alternating AC source to this series RL circuit, and I will be the current flowing through this circuit at that time, and which is flowing through this resistor and this inductor, and due to the flow of this current through this resistor there will be some voltage drop across it that is represented as VR, and due to the flow of the same current through the inductor, due to the reactive effect of this inductor, there will be some voltage drop across this inductor, and that will be VL. Okay. In the case of a series circuit, the current in the series circuit, the current will be same for each and every element. Okay. The I is the current which is flowing through the resistor, and I is the current that is flowing through the inductor also. And due to this, VR will be the voltage drop across this resistor, and VL is the inductive drop, or due to the inductive effect, the voltage drop across the inductor will be VL. Okay. And based on this concept, we can write some equations based on this. Okay. First, let us write the equation for the voltage drop across the pure resistor due to the flow of this current. What will be that? We can represent the voltage drop across this resistor as VR, and VR will be the product of current and the resistor, right? So we can written as VR will be equal to I into R, and the voltage drop across, this will be the voltage drop across the resistor. Okay, this will be the voltage drop across the resistor, and voltage drop across the inductor will be represented as VL, and this VL will be equal to I into the reactive effect of the inductor will be written as XL. XL is the inductive reactance, and the unit of this resistor will be ohm, and the inductive reactance will be ohm, and this XL will be 2 pi FL. Okay, value of XL will be 2 pi FL, or we can say omega L, and omega is this 2 pi F will be omega. Okay, omega will be related with the frequency. Okay, we know that in the case of a pure resistance circuit, what will be the relation between current and voltage, or what will be the phase angle in that case? We know that in the case of a pure resistance, if it is the resistance and I is the current, and we be the voltage drop across this, the current and voltage will be always in phase with each other in the case of a pure resistance circuit. Okay, if it is current and the voltage will be in this direction, and there is no phase difference between current and voltage, or it will be zero. And in the case of a pure inductor, what will be the relation between this voltage and current? We know that in a pure inductive circuit, the current which lags the applied voltage by an angle 90 degree. Okay, current which lags the applied voltage by an angle 90 degree, or we can say that in a pure inductor, current voltage will lead current by an angle 90 degree. Okay, and based on this concept we can draw the phasor diagram, the resultant phasor diagram for a series RL circuit. Okay, phasor diagram. For this phasor diagram, first this can be the current which is flowing through this circuit, and this current is common for both resistor and inductor. And in first we can draw the phasor diagram for resistor. Okay, if I is the current flowing through the circuit, then what will be the voltage? VR will be the voltage flowing through the resistor. Okay, and in this pure inductor, what will be the voltage? Voltage leads this current by an angle 90 degree. So this can be VL. Okay, this volt okay, if we are going in this anti-clockwise direction. Okay, due to the flow of this current in a pure inductor, the voltage which will leads this current by an angle 90 degree. Okay, and we can draw the resultant for this circuit. Okay, and in this case this can be the resultant vector, and this vector V will be equal to, this will be in vector because along with the magnitude there will be some phase difference, so that we choose vector here. So resultant vector V will be equal to the sum of what? VR and VL. Okay, the resultant vector V will be the sum of the voltage due to this resistor and the voltage due to the inductor. Okay, the resultant vector V will be equal to VR plus VL. Okay, this VR is nothing but I into R, and VL is nothing but I into XL, and XL will be omega L, or otherwise we can written as 2 pi FL, I into 2 pi FL. Okay, this is the major things about the phasor diagram, and based on this, okay, from this phasor diagram it is very clear that in the case of a pure RL series circuit, the resultant vector V is drawn here, and the I is here. I is common for both resistor and inductor. Okay, so the resultant I will be this and the voltage will be this. So here phi is the angle. What is this phi? Phi is the angle difference between this voltage and current, or the resultant voltage and current in this pure RL series circuit. So it is very clear that in pure RL series circuit, the voltage which will leads the current by an angle 5 degree, not 90 degree like in the case of an inductor, but it is exactly 5. Okay, or otherwise we can say that in the case of a pure RL series circuit, the current which will lags the applied voltage by an angle phi or theta degree. Okay, it is very important for some technical exams, and we can remember this point. So in pure RL series circuit, the effect of inductor is much higher than that of the effect of resistor, because in this pure resistor, in the case of this pure resistor, voltage and current will be in phase with each other, and in in the case of pure inductor, the voltage which will leads or current which will lags by an angle 90 degree. And here we are discussing about the flow of alternating current through this RL series circuit, and this series circuit, the current which will lags the voltage by an angle 5 degree, and this phi is located in the first quadrant, so we can say that it is less than 90 degree, and which can be a positive value. Okay, and based on this we can write the instantaneous value of current in this case, and this instantaneous value of current, small letter I, can be what? Im sine omega t minus phi or theta. Okay, phi or theta, what will be this? Omega t minus phi, this will be the phase angle. So in pure RL series circuit, the omega t is the phase at the time t, and v will be equal to Vm sin omega t. And in the case of current, at the same time t, the phase will be omega t minus phi, and at that time I is equal to Im sin omega t. So there will be some phase difference of omega t minus phi. Okay, in pure inductive circuit, this instantaneous value of current will be omega t minus 90 degree. Here it is not exact 90 degree, but it will be less than 90 degree, or between 0 and 90 degree. Okay, and based on this we can draw the waveform also. Okay, what will be the waveform? Let us consider that this angle, okay, here it can be omega, here can be voltage or current can be represented here. This can be the equation for voltage, and that can be V is equal to Vm sin omega t. And what will be current? Current will be, it will not in phase, and it will not 90 degree lag, it will be lags by an angle 5 degree, so that this can be pi by 2, this can be pi, and this will be 3 pi by 2, and this will be 2 pi, and the current which will starts from here and flowing like this, and this current I, small letter I, is equal to Im sin omega t minus phi or omega t minus theta. Okay, omega t minus phi. Current lags by an angle 5 degree in this case. I think it is very clear. And this angle can be 5 degree. Okay, this is the main point about the waveform. And next we can, based on these concepts, we can go to the voltage triangle. Okay, voltage triangle. Okay, we can draw the voltage triangle here. Okay, it can be phi, and it is exactly 90 degree, 0, A and B. Okay, based on the factors that we studied here, Here we can represent voltage across the resistor, that is VR, and here it will be VL, and the resultant voltage can be in this side. It can be a rectangular triangle, and the hypotenuse will represent the resultant vector or the resultant voltage. Base represents voltage across the resistor, and this will represent the voltage across the inductor. Okay, and like that. And from this triangle, by Pythagoras theorem, it is very clear that the resultant voltage across OA, that voltage V will be equal to, what will be that? Square root of base square plus this AB square. Okay, so VR square plus VL square. And what is VR? VR is nothing but VR is equal to I into R, and VL is equal to I into XL. Okay, so VR square can be I into R square plus I into XL square, and I can be taken outside I into root of R square plus I into XL square. Okay, but what is this R square plus, sorry, I is not here, I is taken outside, so R square plus XL square only here. Okay, so what is this R square plus XL square? It is nothing but impedance. Okay, impedance. So voltage V will be equal to I into Z in this case. Okay, and I can draw the voltage equation once again here, that is V is equal to I into Z. Here Z is nothing but square root of R square plus XL square. Okay, so we can say that impedance is nothing but the net reactance. Okay, net reactance means the resistance of both, it includes the resistance of both this resistor and the resistance of the reactance of this inductor, that is impedance. Okay, that is inductive reactance, that is XL here. So impedance is nothing but the net or the total reactance offered by this series RL circuit for the flow of current through this R and L. Okay, I think it is very clear, and based on this I can draw an impedance triangle here. Okay, impedance triangle. Okay, the unit of this impedance will be ohm. Okay, unit of resistance will be ohm, and inductive reactance will be ohm. Here the impedance will be ohm. Okay, and based on this I can draw the impedance triangle. Impedance triangle. Okay, in impedance triangle, in the positive x-axis, here will be the resistor, here will be the resistance of the inductor, here will be the impedance or the net reactance offered by this circuit. Okay, I got this XL and R when I divide this equation in the voltage triangle. V is equal to I into Z, and VL is equal to I into XL, and VR is equal to I into R, and I divide each and every term with this current, because current is the common factor for both resistor and inductor. So when I divide this each and every term with current, I will get the impedance triangle. In this triangle, the base will represent the resistance, and this portion will represent the reactance, and this hypotenuse or the resultant will be the net impedance of the circuit, and phi will be the angle between this resistor and the impedance. Okay, and based on this impedance triangle, it is very clear that the value of R will be equal to Z into cos phi. From where I got it? We know that cos phi will be equal to adjacent sides divided by the hypotenuse. Here the hypotenuse is impedance Z. Okay. And what will be XL? XL is nothing but Z into sin phi. Okay, from where I got it? We know sin phi will be equal to opposite side of the theta or the phi. Opposite side is XL here and XL by impedance or the hypotenuse. Opposite side by the hypotenuse. Okay, so we will get the value for resistor and inductor in this case. Okay, next we can think about the rectangular form for the impedance, that is Z is equal to R plus J into XL. Okay, this will be the rectangular form. Okay, and next we can discuss about the impedance in phasor form. Okay, phasor form, the equation of Z will be equal to, Z is equal to root of R square plus XL square. Okay, and one more will be there in polar form. Polar form Z will be equal to Z angle theta degree. Okay, these are the major things about impedance triangle. And in pure RL series circuit, this phi will be always positive, will be less than 90 degree, and this theta is lying in the first quadrant in the Phasor diagram. Already we seen about it, very clear. Okay, theta will be always positive. Okay, next we can derive an equation for the instantaneous power in this RL series circuit. Okay, power, we know that the value of instantaneous power, P will be equal to product of voltage into current. This will be the instantaneous value of voltage and instantaneous value of current. What will be the instantaneous value of voltage? It is nothing but V is equal to Vm sin omega t. Okay, so V is equal to Vm sin omega t into value of I, that is Im sin, okay, that is I is equal to Im sin omega t minus phi. Okay, so we can write it here into I is equal to Im sin omega t minus phi. Okay, that is equal to Vm into Im into sin omega t into sin omega t minus phi here. Okay, this will be in the form of sin A into sin B. Okay, sin A into sin B. What is sin A into sin B? It is nothing but half of cos A minus B minus cos A plus B. Okay, we can write it here. we can write it here as sine A into sine B will be equal to half of cos A minus B minus cos A plus B. Okay. So I can replace this sin omega t into sin omega t minus phi by using this formula. So I can write it here as Vm into Im into half of, so that half of cos omega t minus phi, we will get cos phi. Okay, cos phi minus cos A plus B is the next term. So cos omega t plus omega t minus phi. So we will get cos 2 omega t minus phi. Okay, I can split the bracket in the next step. Vm Im by 2 into this cos phi minus Vm Im by 2 into cos 2 omega t minus phi. Cos 2 omega t minus phi. Okay. And this will be the constant part in this equation. Constant part in this equation. And this will be the pulsating part. Okay. For a complete cycle, this term will be 0. Why? Vm Im cos 2 omega t minus phi divided by 2 will be 0 for a complete cycle. Why? It is because here the frequency is doubled than that of voltage and current. Okay. Omega is equal to 2 pi f. Here omega t is, here it is 2 omega t. So that the frequency is doubled than that of, but voltage and current is not doubled in this case. So that it is very clear that power over a complete cycle, this pulsating part will be 0. Okay. So that finally we can written as P will be equal to Vm Im by 2 into cos phi or cos theta. Okay. Okay, I can rearrange this, or Vm by root 2 into Im by root 2 into cos phi. Okay. What is this Vm by root 2 and Im by root 2? That will be the RMS value of this voltage and current. So capital V and capital I into cos phi. So this will be the equation for power in a pure RL series circuit. Okay. And based on these concepts, we can next discuss about the power triangle. Okay. Power triangle. Okay, it consists of mainly 3 powers: apparent power, active power, and reactive power. I can draw the triangle. This will be the angle phi, and the base will represent active power, and this will be the reactive power, This will be apparent power. Okay, first we can discuss about active power. Active power. What is this active power? It is normally represented by the letter P. Okay. What is this active power? It is nothing but the power consumed by the load. Okay. Or we can say that it is the product of voltage and current. And this voltage will be the applied voltage and current will be the that is supplied by the load. Okay. So active power is nothing but the power consumed by the load, and its unit is in watt, or otherwise kilowatt. Okay. Next is reactive power. It is normally represented as the letter Q, and this will be the product of applied voltage and the reactive component of the current. Okay. This will be in product of VA and R. Okay. It is the term which is related with the reactive component of the current. So the product of the reactive component of current and the applied voltage. That will be the reactive power, and its unit will be VAR. Okay. And the third point is apparent power. It is represented by the letter S. Okay, the unit of reactive power, that is VAR, and the apparent power will be nothing but the power which is supplied by the utility, and it will be the product of applied voltage and current. Okay. Normally its unit is V into A, otherwise kVA. Okay, that is the apparent power. And based on this concept, we can think about an important point, that is power factor. Power factor is nothing but the ratio of active power. Okay, another name for active power will be real power or true power. Okay, we can remember these terms. Okay, power factor is nothing but the ratio of active power to the apparent power. Active power by apparent power, that is, active power is nothing but, here it is, power P is equal to VI cos phi, and the reactive power Q will be equal to VI sin phi. Okay, so we can write it here as VI cos phi divided by V into I. Apparent power will be V into I. Okay. S is equal to V into I. So we will get power factor will be equal to cos phi. Or simply we can write it as the ratio of resistance to that of impedance. Okay. In pure series RL circuit, the power factor is positive and which is lagging, because current is lagging here at an angle 5 degree. Next is Q factor. Q factor is nothing but it is the reciprocal of power factor. So that what is that? Apparent power divided by active power. And we will get 1 by cos phi. Okay, or otherwise we can write it as Z by R. R is very very small when compared with the inductive effect. Okay, these are the major points that we studied today. What are they? RL circuit, voltage across the resistor, inductor, and the Phasor diagram. From this Phasor diagram, it is very clear that the current is lagging here at an angle 5 degree with the voltage. Okay, and waveform can be like this, and voltage triangle. From this voltage triangle, we introduced a new term, that is impedance, and next we studied the impedance triangle. Okay, how it is, how resistance and inductive reactance related with the impedance. It is nothing but the net effect of resistance or the reactance offered by the RL series circuit to the flow of electrical current, alternating current through this. And we derived an equation for power in this RL series circuit, and it will be P is equal to V into I cos phi, and V, I are the RMS values of voltage and current. And next, based on this, we studied the power triangle, and what is meant by it is active or true power or real power. It is nothing but the power which is consumed by the load. Okay, and we studied about reactive power, apparent power, and power factor, and finally quality factor. Okay, thank you.